Welcome everyone to the August 31st SIG Node meeting. Meeting is recorded. It'll be uploaded to YouTube shortly afterwards. Light agenda today. I think the first item Kevin had put up around getting an item tracked in CEPS that I know Dawn and myself got labeled with the right milestone, so I think that's settled. Renal, I think you were just pinging that you had an issue you wanted to talk through. Do you want to?
Yeah, sure. So I've been doing profiling and CPU memory usage analysis on the node side. And one thing I noticed is in Cryo, we used a library, a parallel gzip library to speed up image pulling and extraction and so on. And that library ends up allocating bigger buffers to speed things up. So it is like, okay, you get 30% speed and wall clock time compared to using the default 32 KB sized buffers. But the problem we run into with something like that is if you don't limit the number of concurrent image pulls, you end up with huge spikes in memory. So I'm trying to find the right balance here. One thing we considered was okay, do we switch away from the library? Like on some devices, we don't care if it takes longer to pull images, but even if, say, I want to use that library to speed up my image pulls, but I also want to stay under a certain memory limit, maybe it might make sense to limit the number of concurrent image pulls that I perform. So we have a serial option in the kubelet, and then we have one that said don't serialize, which I'm assuming it does everything in concurrent. So I want to bring up whether we ever discussed having a limit on the number of image pools we can do concurrently in the kubelet, and does it make sense to add one? So we have we can put a cap, or we can adjust our memory usage so it is predictable.
Couple of thoughts here. I don't know the history whether it was discussed before, but do you see how it can be done on Cryo level? Like, can Cryo decide?
Yeah. So Cryo can do it, but the problem there is then we'll have to deal with the kubelet asking Cryo to pull an image, and then Cryo saying yeah, and then just it doesn't get to it, and just additional back and forth between the kubelet and the Cryo. And I feel it might be cleaner to do it on the kubelet side, because it controls, we already have a serialize, don't serialize flag. So on top of that, if we have, okay, do 5 pulls or do 6 pulls, anyways, you're going to be saturating your network beyond a certain number, and you won't be able to pull any more images. So having such a tunable may be helpful, and especially useful in low memory edge node kind of scenarios.
So historically, we just had the serial image puller to begin with, and then we had a knob internally that never got exposed externally on, if I recall, on the number of the size of that queue that could be in that image pooling. For the parallel puller, I was trying to refresh my own memory on this. I don't think we had anything that capped that queue. Mm-hmm. Would you have, did you do anything, Renal, to inspect on what the number of concurrent parallel image pools would be? It used to be that we didn't do parallel image pools because it was unsafe, but we're past that problem now. So
yeah, we are past that. I haven't seen the code yet, Derek. I'll look into it, and maybe I'll get some more data and I'll come back next week. I just wanted to throw it out. This is what I observed, and if it made sense to have some cap on that.
You talk about the memory usage is high, right? And if we add some limit to are you talking about adding just the concurrent number, or are you going to propose to add some resource limit that content runtime cannot use more than what when pulling image?
Yeah, so my goal ultimately is I should be able to come up with a number that, hey, I am doing so many image pulls, I am running so many pods, and I'm running so many containers. And for a particular version of Go, my memory usage should be predictable.
Okay,
And
I see.
and like doing it, like I think with the changes going into the Go runtime, it may be hard to do it with just the like having a memory limit, but to have these knobs, and then for each version we test and publish, and at some point will stabilize when Go VM doesn't change. Like recently I saw some numbers that Go 117 reduced the RSS usage drastically. We haven't yet tested with that, but that may help. But the problem I have right now is like we don't have a cap, and because of that, like any kind of system reservation or any alerts that we set up in that area are meaningless, because if you have a spike in the number of image pools, that number could go up, and then your Go VM is going to hang on to that memory for like 5-10 minutes, and customer is going to get alert. So I want to put a cap on that, so at least I know with my testing that cryo will never exceed this number, or I can go and change the code that, oh, 1 MB is too big, so I want to make my buffers to be like half of or 1/4 of that size, so I can trade off like how much my image pull time is versus how much memory and CPU it's using.
I see. Yeah, I think it. I think it makes sense to me. But I just want to also mention one thing that I think at least in containerd, there's also there's another concurrency configuration there. That is for each image, how many layers
Yeah,
it can pull in
Yeah.
parallel. So maybe we need to
Yeah.
configure. Yeah, I mean, when people use it, they need to know that they need to configure both of them.
right.
So
Yeah, exactly.
Yeah.
So yeah, it's also we
just
had
add one more thing.
yeah we had the same. So we had one at the layer size, but we didn't have one at the image size, and we added that. But I thought it will be cleaner to do it from the kubelet than like enforcing it in the runtime directly.
But just to confirm that, Mernal, did you try running the serial image puller in this test flow and see if it actually did what you expected?
No, Derek, that's on my list for this week. So I'll try that out and see like what the memory usage is after a cluster comes up with serial versus parallel.
I mean, I have no conceptual issue to it. I mean, it's just the size of a channel that we're filling in the current parallel puller. So we could try to find the right balance.
Thanks.
Awesome. Thanks, Mernal. Next item here. Oh, the agenda is growing. Next item, so I was looking for feedback on pods that have ephemeral containers. I have not read this linked issue. Have any of the other folks on the call reviewed this?
Like just to provide a little bit of context on the issue and like what the idea behind it was. The original cap for ephemeral containers mentioned that for cluster administrators to like identify pods that had ephemeral containers created, a new pod condition would be added, and that pod would be added like for that pod, and through that pod condition it would be recognized that said pod had an ephemeral container created. Now that wasn't implemented so far, but hopefully in 123 that should at least like we're hoping to try and implement that. So what I wanted to try and get feedback on is, so if you go through the issue, there is discussion around two major themes. One being, should we add pod condition to only pods that have ephemeral containers created, or should this pod condition also be applicable to pods that have kubectl exec executed on them? So what I basically wanted to try and get feedback on is, do we add like under one pod condition, do we cover both of these cases, or do we not need a pod condition for kubectl exec and just work on ephemeral containers? on this new like added pod condition, or like along those lines, along those lines.
Yeah, I was just bringing up the ephemeral containers kept to refresh my memory on the proposed tainting. I know, at least speaking from our experience at Red Hat dealing with users of Kubernetes, we have a number of users that want to proactively disable the usage of exec. Those same users would probably also proactively disable the usage of ephemeral containers for a security posture. The one thing that's given me pause on maybe speaking to your question exactly is the other KEP that's put forward right now to handle container notifications. I don't know if Seth's on the phone, but we've talked about this previously. That was kind of like a way of doing exactly like execs, and I'd want to think through if applying that condition would be desirable or not. Are you familiar with that proposal?
No, not. But thanks. I'll take a look and get back.
For the moment, though, I think it's fine to start with a distinct condition related to the usage of ephemeral containers, and then let's treat exec separately.
Okay. Yeah, that sounds good. Thanks.
Do others have a different perspective on that? Okay. Just looking at the CAP, but we didn't actually name the condition in the related part of the CAP. On the issue, is there a proposed name for this? And maybe I've just missed it.
No, not yet. So I think there might be a mention of one on the issue, but that was just to that's just like a placeholder of sorts to like drive discussion, but there's nothing proposed as of yet.
Okay. If we look back, if you look back on the notification API cap, which I'll paste in the chat, that also maybe we would want to think about if there would be a condition tied to that, because that's basically a way of doing execs without doing the end user initiating the exec. So if you want to take a look at that and then maybe come back next week and give your thoughts on it, I think that'd be great.
Yeah, that sounds good. Thank you.
All right, and then it looks like we have one other item on the agenda, which is calling to a linked issue. Is it? Do you want to summarize the?
Yeah, so we were experimenting on Windows with running the sandbox container as different users to match Linux functionality, and we broke something. What we know what we broke, but we saw an interesting behavior come out of that we wanted to just double check here, is that if the sandbox container fails to start, the pod stays in a pending state, and you can look and see the errors. If you describe the pod, you'll see the error, and you'll see the error in the qubit log, but the pod itself will stay in the pending state. And then we were taking a look in the kubelet, and it doesn't look like some of the lifecycle checks check the state of the sandbox container. So we were wondering if that was an oversight because it just doesn't happen on Linux that much, or if nobody noticed that, or if there was any intention behind that. Yeah, I think that's the question.
That's a good question. The phase calculation, if we bring up that part of the kubelet, I'm just thinking out loud, in the scenario described, I would still expect things like active deadline seconds if that was on that pod and that pod had never actually started at Sandbox. The kubelet should still destroy that pod. But I think pod phases generally was a tough thing to think through here, in the sense that there isn't like a great phase that a pod in that set could go to, and it was kind of a fixed state machine. So was there something, Mark, when you were looking at this, that you thought it made more sense to be in?
I think we were wondering if like the whole pod should go to failed eventually.
Oh,
Well, when is eventually? Because it makes sense to me that it'd be in pending if it was trying to create the sandbox.
We saw it stay in pending for like 15 minutes. That seems a bit excessive.
yeah, so I would expect it to stay pending forever. We'd have the same issue as well if like the CNI hadn't yet been deployed on that node, right? Where the sandbox also wouldn't create. So
okay, I guess that makes sense. We weren't sure if there was reasoning behind that, but if there's a situation where the pods are pending because we're waiting for a CNI to come in to set that up.
Well, once they go failed, they'll never retry to create the pod. So that's probably not what we want, unless like the pod is irredeemably cannot be run.
But if you have a failure, yeah, I guess it depends. In
Like,
our case,
pods are mortal. So if the pod goes to failed, it's not getting restarted.
what was the reason though that were you expecting in the situation you were exploring that the sandbox would eventually successfully create?
No, there was an issue in the way that we were trying to start the sandbox where it would never create. And we also do see this occasionally. So with on Windows, each like the container image needs to be paired to the container to the OS that it's running on. So each new version of Windows that comes out, we need to add a new image to a new container image to the pause image that we publish or that we build and release out of Kubernetes. And we have seen in the past that when if users update the OS versions and don't take a new pod or don't take a new pause image that contains a container image that matches that, the sandbox image won't start, and then you get into the same state.
Yeah. So the behavior you're seeing, I think, is as intended, and maybe what this is a reminder of is like I think pod phase is probably the thing identified as like one of the errors of Kubernetes, and so versus uses of conditions generally, and we can't say that it's running, and we can't add a new state, and we can't destroy the pod. So I think unfortunately, like where you're at right now is our hope would be that the sandbox gets created successfully, or if something else had to go and reap these pods, they would have to do that themselves.
Okay, yeah, we're not necessarily looking. We weren't necessarily looking for a change of behavior, but we were just wondering if there was intention behind that, and it sounds like there is.
Yeah. So. Yep. Okay. Well, thanks for raising the question.
Okay. Yep. Thanks. Thanks for answering that.
Any other topics for today? Otherwise, I think happy to give folks back their time, and we'll try to get through tech reviews.
Actually, not a new topic, but question to previous one. So would it make sense to also combine that with a problem when the runtime is not able to create a sandbox and pod required to be evicted from the node and reschedule it somewhere? Or in this particular case, rescheduling it to another node will not help?
I'm very sorry, Alex. My daughter came in and wanted to show me a new shirt at the same time you were speaking, and I was trying to get her to leave the room. Can you,
No problem.
Can you repeat that?
My question is like with scenario for this when the sandbox creation failed, would it help if this pod will be evicted from the node and then rescheduled somewhere?
Well, so in the case of the CNI failed, and that's the reason that it's pending, we don't want that because then we'd end up with like mass evictions. Sorry, I see that this was also discussed last week, but I was out of office, so.
Well, I also was not present last week, so I don't know the context. But I was just curious, if we have a scenarios when, let's say, like this pose image mismatch, and for some other reason, like we have a scenario what runtime is not able to satisfy creation of pod or container. Would it make sense to have an error message from the runtime saying, well, sorry, I cannot do that on this particular node?
I think normally that would be...
I understand what CNI might be not a good case for this error, but this, let's say, post container mismatch might be.
Normally, I think that'd be surfaced as events from the pod, right?
I don't know, Mark, what do you say?
Yeah, we did see events saying that we couldn't start the container failed.
Yeah, I think.
So I think somebody could listen to that. And
yeah, and the
act
other,
on it.
Alex, I mean, I think generally there's no shortage of higher order things that could go and write a controller to reap that pod and hope it gets rescheduled elsewhere. But I don't think the keyboard itself can make that choice.
Even if we will have some hints from lower layers, like from runtime, what, like for some reason this configuration of a pod or something is not possible on this node.
Yeah, I just don't know if the decision the kubelet would choose to make would always be right. Like, so take the CNI choice. Let's say you're running a single node Kubernetes, and when you do lifecycle maintenance on that single node Kubernetes, you don't drain your workload because there is no other node for it to go to. You restart your box. Behavior right now for kubelet is that it will just try to restart all pods that had previously been scheduled to it. Pods had been scheduled to it that said they expected a CNI. And if we have a situation where we try to start a pod that the CNI wasn't present yet because the CNI itself hadn't had its daemon set launched, like you wouldn't want to.
Yeah, I understand the CNI case. I'm more worried about this infrastructure containers, what Mark mentioned, which is a bit more problematic.
So, but like the usage of a pause container itself, for example, is not uniform across all runtimes. So Cryo itself doesn't always start a pause container depending on what the pod needed. So it's kind of opaque to the kubelet at that point.
It seems like the issue is determining when you want it to be a retriable failure or a terminal failure.
Yeah.
Yeah, and that was the background of my question. Like, should we have a scenario with runtime returns the error, which says like, regardless how much you try it, I can't run that spot on this node.
But let's take the CNI scenario. Wouldn't it do that if no CNI had been deployed?
I don't think so, because we know what CNI is something that can be repeated. I'm more about what scenarios would, like for some reason, sandbox creation is failing. well, might be like hypothetical example, but let's say we have a VM-based runtime, and for some reason, like it's configured, we put a scheduled runtime class set for this VM-based runtime, but let's say like virtualization is not enabled on the node. So regardless how many times you try, the hypervisor will say, sorry, VTX is not enabled on this node, I cannot start it properly.
So Mernal, you had looked in the past on maybe enriching error handling responses from CRI to kubelet. Maybe Alex, if you had a few examples, we could look at trying to enrich that API that's so that the kubelet could make a decision that says the runtime's telling us there's just no hope.
Okay, yeah, I'll chat with Ronald when.
Yeah.
I see
This
Deep
is
is
Deep.
unmuting. Oh, there you
Yeah,
go.
sorry. Yeah, I just wanted to call out that we see similar cases with the kubelet volume manager as well, where the CSI plugin might try to basically attach or mount a volume. And the kubelet just basically continues to retry through the kubelet volume manager, even though it might be a terminal condition where the CSI plugin may not ever succeed, right? So it just continues to try to attach and mount a volume. So kind of like a similar scenario that surfaces in the storage side as well. Just wanted to call that out.
So I wanted to add one example as well. So yeah, similarly with the mismatches as well on Windows, not only with both, if one of the customers is using image that mismatches a host, then we end up in similar scenario as well, where we keep retrying to recreate the sandbox, but this will never run on this host. So I agree with the point of Alex, if we can filter some types of errors that, yeah, really runtime can run this pod anyway on this node. And then in this case, we should try elsewhere or stop, yeah, trying to run it.
The other thing that we could think about in this is, this sounds like just like a startup problem. So we have deadline seconds, which basically says how long this pod can run on this node before the kubelet proactively reaps it. Maybe we could think about use cases of like startup periods. Let's say if this pod doesn't start up in period X, then the kubelet also should proactively reap it.
But Derek, my also second reason for the question was like, yes, with all these deadlines, we can have a scenario what pod will be marked as failed. But maybe we should have a scenario to report to scheduler what we need to find another place for this pod.
That's not captured with disk pressure or PID pressure or one of the existing pressure signals.
Well, for a good example of this CSI plugin, so what for some reason the volume is not possible to attach on this node. So find another node where this volume also will be available.
Yeah. So I'm sure there's like specific scenarios we could work through. So yeah, maybe Alex, if you had a few, like I said, if we had a way from the CRI to the kubelet to advertise this has no more hope, then maybe we could think about proactively terminating that pod. I'd have to think more on the volume scenarios, but
Yeah, I was going to say that I don't think that would cover the volume scenarios, but that would could potentially cover both the CNI, like waiting for CNI, and just this container's not going to start.
Yeah, so that's practically applicable to any of the extension to the kubelet. So when well, I wouldn't bring the device plugins, but it's also possible scenario what like, yes, you can try to allocate the device, but for some reason I cannot satisfy this device request and it needs to be moved out from the node. So it's probably a generic thing to say what this pod for some reason is not runnable on this node and needs to find a new place. And we need to have that from storage interface, from runtime, from device plugins, or whatever else extending mechanism we might have.
Yeah, I agree, Alex. But just for the case of the device plugin, though, I thought that the expectation would be that the device plugin dynamically updates the allocatable number of devices on that node, so that if the device was unhealthy, that it's not going to be counted by the scheduler. Anyway, I think each one of these is complicated to reason through. So if there were things just from CRI flows, maybe we could focus on one call in particular, like start pod sandbox, and find out if there were well understood terminal cases that we can respond to.
Okay, sounds good. Yeah, I think that could help us here. And
all right, well, I think that is today's agenda. Just a reminder, I think the dates for KEPs are September 9th. So I hope to get through a lot of them this week, and I'm sure the other reviewers will do their best as well. So we will meet again next week.
There's also a soft deadline from the production readiness team that if your KEP is not, if it doesn't have the PRR questionnaire filled out and ready by, I think, this Thursday, 1 week before the deadline, we may not get to yours. So please ensure that if you want to get your PRR approved, that your KEP is up and has the questionnaire filled out by this Thursday.
Awesome. Thanks, Alana. And we'll see you all next week.
thanks.
Thanks.